GPUs are in such high demand, and they're pretty well regulated, to the point where it's really hard to get your hands on them. None of these companies have the budget to go out and buy the gear themselves. These cards cost $30,000 plus a piece, so they're not going to be able to convince their investors to, hey, let us go buy these fancy toys. They're like, no, we're going to go buy a Lambo with that instead. Because, it ends up being that much. When each of these servers has 8 GPUs in it, one of these servers sitting on the table, we're like, this is a piece of hardware that's worth as much as a house. They were projecting that half of the power generated in the US by 2032 to 2035 is going to be used in data centers. That is crazy. So what do you do about that?
Welcome back to the Middle Tech Podcast. You've got Logan Jones here today. And for this conversation, I sat down with Ian Girard, who is the founder and CEO of the Cloudminders. So the Cloudminders is, as they phrase it, a GPU as a service company. And so if you're not familiar with what GPUs are, they're specialized computers that run the software required to run artificial intelligence programs. And so what the Cloudminders is doing is allowing people who are doing things like AI research or needing to fine-tune different types of models to do so on their AI infrastructure, their GPU infrastructure that they are building out. So they're taking a unique approach to how they are funding this business, how they're differentiating it from something like an Amazon Web Services or a Microsoft Azure. So it's a very interesting conversation about a different approach to providing AI infrastructure to businesses and teams that need it. There's obviously a lot of tangents that you can go down around AI, and we got to explore some of those, talking about building out the infrastructure, these data centers that actually power artificial intelligence, things like where they're getting their energy from and what that's going to look like into the future. So we got to nerd out a little bit about things like nuclear energy, and where exactly all of this could go into the future. Is artificial intelligence an existential crisis? Was one of the questions that was asked within this interview. So really fun one. Just me on this one. Evan is traveling again, so we should be back together for next week's episode. But for this one, I am rolling solo. So hope you guys enjoy. It was a really fun interview for me. And before we dive into this one, I just want to get a quick word from our sponsors. Before highlighting our sponsors, we'd just like to state that the views and content shared on this platform do not necessarily reflect those of our show sponsors. Middle Tech is presented by KY Innovation, the Kentucky Cabinet for Economic Development's Office of Entrepreneurship. KY Innovation exists to support and develop Kentucky's startup ecosystem, and we are proud to be supported by an organization whose mission aligns so closely with ours. If you're a founder building in Kentucky, you need to check out the resources that KY Innovation has to offer. You can find more information by clicking the link in our show notes or going to kyinnovation.com. Middle Tech is sponsored by Bolt Marketing. Take your website to the next level with a website that's built to work. At Bolt Marketing, they're revolutionizing websites for small businesses that are affordable, customizable, and hassle-free. Whether you have a construction company, a boutique clothing store, or you own a hot yoga studio, they have options for you. Click the link in our show notes to explore their marketing options that can transform your marketing and grow your business. And as a personal note, Bolt Marketing built our website, and they were awesome to work with throughout the entire process. We highly recommend working with them. Middle Tech is also supported by Huntsicker, an impact venture studio based in Lexington, Kentucky. Huntsicker is creating companies out of the ordinary by founding and funding the next generation of purpose-driven startups. They partner with founders to create indispensable solutions to the world's most fundamental problems. On a quarterly basis, they host an invite-only intimate gathering called Fireside Convos, where attendees representing a wide network of stakeholders in the regional entrepreneurial ecosystem discuss timely topics, including the role of AI for startups out of Kentucky and the challenges of identifying and attracting talent. To be considered as a guest, visit huntsicker.co/fireside to apply. All right, welcome back to the Middle Tech Podcast. You've got Logan Jones here. We are recording out of the office of JP Blevins, so big shout out to JP for letting us use his space. I'm sitting down with the founder and CEO of the Cloudminders, Ian Gerard. Ian, you drove a long way to come here and join us in person, so I want to say thank you for that.
No, of course, man. Thank you for having me. I appreciate it. It's
yeah,
a nice
absolutely.
little spot you got here.
Yeah, and I got to give a shout out to your all's CMO, Adam Taylor Brown. He was super helpful in getting us organized here and did something that no guest has done before for the podcast, which is he helped me come up with the best talking points for you guys, which was super helpful.
He's
to do. Very thorough.
Yes.
Yeah, just wanted to give a shout out. You guys on the podcast might know him from Marrow, but needed to give that shout out to Adam before we get started.
Awesome.
So super excited to dive into the Cloudminders. You guys are in the AI space. Mm-hmm. Obviously, a lot of buzz going on around AI, GPUs, compute, all of that sort of stuff we're going to be diving into today. But the place I like to start these conversations as kind of a goofy question. I like to ask, how do you describe the Cloudminders to your mom?
Oh my gosh, to my mom? That's so funny you say that, because for the last like 7 or 8 years, she's been describing my business as a reference to Parks and Rec. Have you seen any of that show, Parks and Recreation?
Yeah, I've watched it before.
So Tom, the Aziz Ansari, he has Entertainment 720, and nobody knows what they actually do, right?
Yeah.
It's just a hype machine. And my mom, she says, I think it's kind of like Entertainment 720. I'm like, Mom, that's a terrible description. So
you might have to correct her on that.
Yeah, I do have to. And so like I try to explain it to her using what we call the apartment analogy, which is, hey, we've got these things called servers. Inside of those servers are smaller units. Like, there's these parts that we're actually using out of them. We rent those out like you'd rent out an apartment. Sometimes people are in there for a day. Sometimes they're in there for a year, just using that hardware and occupying that space. So that sort of works with my mom, but generally speaking, I'm like, you know how like AI is like taking over the world and everything? She's like, yeah. I was like, that's us. She's like, oh, okay. So that's the easy way to describe it.
Yeah, I always like kind of starting at the foundational level and then building the understanding from there. So let's talk about the actual hardware that your business is kind of built around. So to try and tie this all together, for those who might not be super technical, talking about how AI actually works. AI is run on specialized computers called GPUs. So maybe just let's start by talking about what is a GPU.
What is a GPU? Yeah, I mean, a GPU, the name of it's actually kind of a misnomer. It's a graphics processing unit. And AI is not all about graphics. I mean, there are some weird AI art things that we keep generating as part of our own media presence right now, but that's only a small component of things. It actually has nothing to do with graphics at all. The reason people use graphics processors, though, is because graphics processors have to be able to keep track of millions and millions of variables all at the same time when you're in a 3D space. Like, think about in a video game, there's all these things being rendered, or in like a Pixar movie, there's all these little details that have to be rendered. And so these chips are made just for that purpose. And it turns out they're really good at doing a lot of mathematical computations that aren't just graphics related. So the way that AI really works, it's kind of a system of averages built out on top of tons of variable data. So you have to have a ton of data. And then what you do is there's a couple different processes you can do. But the way that I like to talk about it is when I was running my first tech company called Adder, we would collect lots and lots of location data. And you can look at that location data and say, okay, I see that this guy went maybe to the Jimmy John's across the street, and then he went to Transy or something. Maybe that guy's a Transy student. The thing about AI is that you don't have to sit there and think about all those questions yourself. You're uncovering those patterns that's just built into the data itself. So it's called hidden Markov modeling. We don't need to go down that rabbit hole. Anybody that knows anything about AI is going to be like, hey, that guy might know something. But I'm not going to describe what that is because it would bore people to tears. But the idea is that you have tons and tons of data, and you're looking for patterns inside of that data. And you can ask that data questions if you train an AI on that data.
Makes a lot of sense. So you guys are kind of dubbing yourselves as a GPU as a service company.
Yes.
Let's talk about what exactly that means. So just kind of explain that from a high level view.
Well, yeah, I'll back up for just a second and be like, the G in GPU should stand for something like generalized at this point, because they're used for so many different things. We might end up renting out a GPU to somebody that's interested in rendering and graphics and things like that. But generally speaking, we're trying to target people that are in the AI space, in the big data space, saying, hey, we'll let you rent one of these chips or 100 of these chips at a time. And you want to pay for it for a minute, you want to pay for it for a year, whatever you want. Come in and use our stuff. We'll kind of handhold you through the process of getting onboarded with all of that, and then let you go to town. It's basically like throwing the keys to your server to somebody and say, bring it back. Don't bring it back empty. That's the only thing. And you can't actually empty a GPU, to be clear. So, yeah.
So talk us through. Let's connect that to the problem that you guys are solving at the Cloudminders. So let's say you're talking to an investor. You guys are raising some capital, and they're asking you, hey, what problem does this solve in the world? Talk about that problem and kind of how you came upon discovering that it was a problem.
Sure. Yeah. The biggest problem that a lot of the biggest problem that we think that we're addressing right now with the current offering is that a lot of developers just have a really hard time getting any pull with what are called the hyperscale data centers, like Amazon Web Services, Microsoft's Azure service, the Google Cloud platform. These GPUs are in such high demand, and they're pretty well regulated, to the point where it's really hard to get your hands on them. If you're a small-time software developer, if you're a small team, a startup, anything that's in that small to medium-sized business category is probably going to have a harder time getting access to these in the first place. None of these companies have the budget to go out and buy the gear themselves. These cards cost $30,000 plus a piece. So they're not going to be able to convince their investors to, hey, let us go buy these fancy toys. They're like, no, we're going to go buy a Lambo with that instead. Because it ends up being that much when each of these servers has 8 GPUs in it. One of these servers sitting on the table, we're like, this is a piece of hardware that's worth as much as a house, at least in 2022 dollars. So that has changed. That analogy no longer works. But yeah, so like the problem right there that really is being addressed here is that these bigger companies don't really give sunlight to the undergrowth in this forest of technology right now. And we're kind of coming out there, not really chopping down trees to allow light to get through, but we're kind of like bringing our own light along and saying, hey,
yeah, lifting people up.
We'll actually take care of you guys. We'll actually pay attention to you guys because the money's still good. We're good at what we do. And we like working with the smaller companies anyway, because that gives us a chance to actually learn something about what the teams are doing, possibly participate. It is an interest of ours to be able to say, hey, we want to consult on this stuff and like white glove it a little bit. So that's something that's a little bit unique about us, is that we like doing that. And I think most of the other companies are just looking at it as a very straightforward, here's some infrastructure, rent it, and pay for it.
Love that. So let's dive in a little bit to talking about the revenue model here and kind of how you guys have structured the business from an investment perspective. Because when we got to connect initially and kind of talk about the business, I think that's a unique approach that you guys have taken there.
Yeah.
So you can start with whichever one of those two you want between.
No, I think like starting with the revenue model, it's kind of what we already talked about a little bit, like the per hour, the per week, the per whatever the period is. You're paying a certain amount of money for a piece of hardware. We usually come in somewhere in the middle of the market on that. We don't like to race to the bottom because we think that we actually offer like value add services. At least we would argue that. So the way that model works, it's pretty straightforward, honestly. We got started in all of this stuff learning about how like things like crypto mining worked and stuff like that. And we're like, there's not in our minds, there wasn't a ton of value in doing that. It was like calculations for calculation's sake. But it's a really interesting thing to be a part of, is like what this infrastructure can actually do, but we can get to that later. As for how we unlocked this to make it make sense, we spent years trying to raise money to buy this hardware, this really high end enterprise grade stuff, they call it. There's consumer grade graphics cards out there, but you don't really want to use those for this kind of work. You can, but you don't really want to. The enterprise grade stuff is super expensive, like I mentioned. So convincing investors to open up their pocketbooks and just give us the money for that was actually kind of tricky. Like we had done probably like 10 or so deal drafts with some pretty big names out there, and they just wouldn't go where we wanted them to go. So we're like, all right, how do we reframe this to actually make it make sense to the people that we're trying to talk to here, and to get that money to actually focus towards us? And it was the REIT model actually worked for us. And that's why I make the apartment analogy. People that are used to developing properties, they understand, oh, if I buy a building with 8 units in it, these 8 units will generate revenue in these different ways, whether it's an Airbnb kind of model, whether it's a hotel, whether it's an apartment. These are all just different durations of time that you're occupying that unit. So we started describing it as such to people that were in the real estate business, people that already did real estate funds. They already understood all that. Like, oh, you rent out rooms. It's like, yeah, they're AI rooms. Let's call it that. And that kind of breaking it down to that level of saying, hey, we could talk about AI, we could talk about technology, we can talk about hardware, but really at the end of the day, this is the model. We buy the box that all this stuff goes in, we run that box, and we let people use parts of that box. So getting it to that level of understanding, this apartment analogy thing, made it so easy to just like, it's like a one-pager now. It's not even that. It's very easy to kind of get that immediate connection with people that are not technical background people. Like they're not from that world. And that's usually the challenge. It's like, oh, this isn't my industry. I don't understand it. Okay, well, I want you to understand it. How do I make that understandable? Yeah. So instead of these people investing directly into us, we more or less, and they're not called REITs, but they kind of are like little individual real estate trusts.
It makes sense. It makes a lot of sense. Yeah.
I mean, they're special purpose vehicles, we call them, but it's the same thing. It's the same idea as a REIT. It's just not a REIT. Put money into a fund. That fund pays us to buy the equipment, pays us to run the equipment. And eventually, after a couple of years, it all turns over into our control after the value of that equipment depreciates out, because, eventually these things do need to be replaced. There is a lifespan for this technology. The cool thing for investors that get into this is that they get this initial, right away, as soon as they buy in, they get this massive tax write-off for buying the hardware because they're buying hard assets. So that's really like, once we figured that part out, hey, your first year doing this, you're going to get like a 60 to 80% reduction in your total risk. And then the rest of it's just money on top of that you're earning month over month, because we have those customers that are moved into these units generating revenue. So it was really appealing to people that were looking for a tax advantage of some kind to offset however much they're making in their real estate businesses, because they're doing pretty well right now, for at least from what I can tell. So they have the extra capital to spend, send it our way, because they need to diversify. And that's really what we provided, was an avenue for them to do that made sense. And with the help of our capital partners, they help facilitate those relationships to where we can focus on what we're good at, going out and convincing them it's a good idea, and then running the actual equipment and doing the work.
It's super creative. And I think it probably makes a lot of sense to communicate in that way to especially investors that are likely in this area.
Yeah.
AI is a brand new thing. So trying to describe like, yeah, we have these servers and these servers are going to generate revenue by, hosting AI software that these people are doing.
They glaze over. Yeah. They're like, no.
Yeah. So I think that's really smart and creative.
Yeah. I mean, that was really like, I describe it as like, that was kind of like us finally getting the last piece of the Rubik's Cube, like lined up, and now all the sides are the same color. It finally makes sense enough to them to where this works. And now we don't really have to do all this extra heavy lift of explaining what the heck AI does. It's like, there's demand. Here's the demand. We'll show you what it's looked like. Here's the proof of what we've done. Here's the, X amount of revenues that we pull from our own equipment that we've already got and from other ventures that people have done with us. And it becomes a very easy to tell story once you have all those numbers in your back pocket.
I love that. I want to talk about vision here for a second. Adam came up with a good question that I wanted to make sure to ask, and it's about the vision for software-defined supercomputers and differentiating that from these GPU as a service marketplaces.
This is definitely where we get into the more technical stuff.
Let's do
the
it.
more esoteric stuff that I'm very passionate about. My team's very passionate about. So how do I break this down as simple as possible? All right, there's AI workloads that run on these pieces of hardware, right? And these pieces of hardware can only handle so many variables. I mentioned billions of data points earlier. Well, these AI models these days are absolutely huge in terms of the literal size that they take up. I don't know what your phone has on it, but a lot of people have like 128 gigs on their phone or something, right? Storage. That's just the storage on there. Now, the actual ability of your phone to process that, it's only got 8 gigs of RAM on there. Right. So a GPU is it's the same kind of idea. It's like, this is RAM, this is short-term memory, load all this information into there. And what happens when you have too much information to put in there? Well, do you just not run the AI, or do you do something else? So what supercompute is these days is essentially like, hey, let's put a bunch of these things together to where they all function as one hive mind, if you will.
Neural network, maybe like they all kind of function.
Yeah, it's all networked together using like very, very high speed networking. Like most people have a gigabit connection at home. These run on a 3.2 terabit connection between each other. It's ridiculously fast because there's a ridiculous amount of data.
Right.
It has to be very low latency. They all have to talk to each other as if they're all sitting in the same computer.
Sure.
So having that extremely fast networking is necessary. But you basically put them all together into one big, unified front where it's like, all right, I'm going to shovel all those data points at you. Massive supercomputer, and you can actually do this. You can build supercomputers, like hardware-based supercomputers. People have been doing that for years. Adam and I were talking about the XAI supercomputer that they're making. That's going to be a huge GPU cluster.
In Memphis, right?
I think, Memphis. It's somewhere in Tennessee. I thought it was going to be near Oak Ridge, but I think that's all. They're all in the same kind of neighborhood. We're in Kentucky. They're down there, whatever. That's their business. But no, so what they're doing is a hardware-defined supercomputer, right? They're building one big thing that is designed for one purpose. What we want to be able to do is to say, okay, it's variable. You need 8 of these cards. Well, we don't need a supercomputer for that. You can just use one of our servers. You need 16 of them? Okay, we'll spin the knob up and say you need 16 now. All right, the software is going to network these things together to where you don't have, as a software developer, you do not have to care about all that hardware. You just know that your computer is faster now and it can handle more data points. So being able to do that on the fly and say, hey, look, I might have set defined pieces of hardware. I'd rather them be more composable into something that's like, I want this for this purpose and I want it to last for this long, and then I can turn it off. And it doesn't require technicians to go out and reconfigure things and de-rack servers, put servers back up on the shelves, that kind of stuff. There's none of that happening. It all happens programmatically and algorithmically. So we've had had some fun doing it.
Yeah, that's awesome. That makes a lot of sense. You did a good job kind of breaking that down to a simpler term. The other thing I want to talk about with AI and GPUs, and this is a big part of the AI conversation right now, is the energy consumption that comes along with running these computers. I mean, just sucking massive amounts of energy.
Huge amounts.
Also, lots of water or methods of cooling these computers as well because they get so damn hot.
Yes.
What's your all's perspective on the substantial amount of energy that it takes to run these things? I mean, let's just kind of dive down that rabbit hole. Sure. We can talk about it from your all's perspective, but also the broader country and like what America kind of needs to do to be able to scale this up.
There was a really interesting chart that we looked at doing some of our marketing stuff after the Supercompute, the national conference last year. There's a company that was presenting, I think it was called Light Matter. Anyway, the point is that they were projecting that half of the power generated in the US by 2032 to 2035 is going to be used in data centers. That is crazy. So what do you do about that? For one thing, you can't really control what NVIDIA and Intel and AMD do when they make the chips run with more power going through them. What are you supposed to do about that? It just needs more power. That sucks, but that's how it is. So it's a little bit incumbent upon them to solve this challenge a little bit, but on the other side of this is the software and how we run AI, how individual developers run AI. You can optimize things to use less energy, to use less of these components, to use less of this just equipment. That's one avenue to hit it from, is just reducing overall. It's the first one, reduce, right?
Yeah.
We can't really reuse any of this stuff. Although actually, we can reuse the heat. And that's something I'm really interested in is like we generate a ton of heat with these chips running. I mean, think of like a space heater that you might turn on in your office. Those are 1.5 kilowatts. This is how much they pull from an outlet, 1,500 watts. The highest end GPUs right now take 750 watts. So 2 of those GPUs equals a space heater. If we put these GPUs somewhere cold where people need to have forced heat, we can actually reuse that heat for something. And so we're not doing that right now, but that is something we're really interested in being able to do in the future. There's a couple companies in the UK doing it right now that are like kind of we look to them as like, actually it's more Scandinavia really, because of course they're going to do that. It's very cold there. The Scandies are always on this stuff, which we love that. And I think that's a good model for us to follow eventually is like reusing this heat that's generated for something useful instead of just saying, oh, we have to get rid of it. But then moving into that part of it, the cooling of these chips is expensive. And like you said, it takes a ton of water.
Yeah, resource intensive.
Really is. I think somebody was saying like 10 queries, like it was last year before ChatGPT optimized a little bit, but 10 queries on ChatGPT would burn a bottle of water.
Yeah, I saw that, which is insane to think about.
We don't have that much water. Maybe if we're like using like saline water from the ocean or something, desalinating it, whatever. But decreasing the amount of energy needed for cooling is a huge concern right now because that's really where you can get, there's only so many areas you can pull from here. And if the chips are going to get hotter, we can't pull from that. But we can make the cooling more efficient. So right now, most everything is done in air-cooled environments. Big, huge fans screeching at 15,000 RPM. You got to put on like headphones or some kind of ear protection.
Of that, yeah.
It's so loud. Yeah, like anytime I walk into the data center with my earbuds in, they're noise canceling, so I can hear. But people are like, "What is that noise?" I'm like, "Oh, I'm sorry. Hold on, let me get out of here."
Yeah.
So air cooling is not super efficient. Just in general, you're using just massive air conditioners that take a ton of power. I think right now the numbers are somewhere between 30 to 60% of the total. Like, so say you have 1,000 watts you're using just for your equipment, like what you're actually trying to run, the infrastructure. Between 300 and 600 watts are added on top of that just to cool that stuff down.
Wow.
So it's a lot of extra power being used. So if you can get that power use efficiency better, then you're not saving the planet, but you're definitely reducing the harm, right? And that's why we were really interested in immersion cooling. So instead of everything being air cooled, we want to stick things into dunk tanks where you basically have like all the equipment's running in this specialized fluid that boils off at a very, very low temperature. Doing the phase change between liquid and gas is really efficient for cooling. So it saves us a ton of power. Basically, it reduces that 300 watts down to maybe like 100-ish watts.
Right.
Is the idea. There's been criticisms of this before, this technology, because the old generation of these chemicals that were used to put the servers in, because you can't put them in water, they'll short out.
Right.
Don't drop your iPhone in here, right? So the stuff that we use has to be like electrically neutral, has to be able to like carry all this heat and then do all the stuff we want. The old chemicals were really bad for the environment. Like they would tear holes in the ozone.
Course, yeah.
Right. There's just no winning.
Yeah.
It feels like sometimes. But we were able to find chemical suppliers. We're doing our own chemical suppliers on this stuff that have a much, much more eco-friendly approach to all this stuff to where it's not a concern of ours on that end of it. Because that was the challenge. That was the criticism of doing it this way was, hey, you're going to tear a hole in the ozone. All right, well, now there's new generation chemicals that companies have made with that in mind, knowing, hey, we have to care about the global warming potential. We have to care about the ozone depletion potential. Yeah. And so now that we're there, it makes sense to use immersion cooling to reduce the amount of power that you're using to cool your stuff off instead of air cooling because like I said, it's loud and people do hate living next to data centers for a reason.
Oh, I'm sure.
They're super noisy.
I'm sure. And this is not something I can speak a ton to, but I know that it's at least going on, something that's happening here in Lexington, Kentucky that actually plays into exactly what you're talking about with the cooling. And that is Valvoline, which is kind of a company you wouldn't necessarily expect to be in data centers and in coolants. You know, they are trying to make their business model resilient as we look at, okay, EVs might be taking over within the next 10 years. How can they make their business model resilient? I have several friends that work there actually that are telling me they're getting into data center coolant. Yep. And finding ways to do exactly what you're talking about, which is kind of make the process a little bit more efficient.
It's a very rapidly moving industry. I mean,
super cool. Super cool.
Literally cool.
But literally, no pun intended. I want to talk just briefly about kind of like, you know, as a country and maybe even globally where we're headed with this. My sort of thesis around AI and where all of this is headed is that the adoption of AI and the implementation of AI into our everyday lives is not going to slow down. I think this is the real deal. I think it's going to be implemented into just about everything, every device that we have, just like the Internet of Things. What's that?
It's been said before that like, you know, automation will save us and it'll be part of our lives. But like that was like the 50s where they were imagining that by the mid 70s, we'd all be in flying cars or whatever. So
this is true. Yeah. This is true. There's always that kind of aspect of it. But my theory is that essentially this sort of it's a new platform to build on. Just like when we switch from on-prem to cloud, it's now kind of a new sort of platform that we're gonna build upon. So because of that, I think the demand for these GPUs, for the compute, for the data centers is only going to continue to skyrocket. We're going to have a lot more need for the energy that powers these data centers.
Right.
I just think that's a super interesting conversation as we think of ourselves as a country, because right now so much of our energy is still coming from, oil and coal. We're getting way up there with gas and solar, but we were kind of talking before. I think nuclear is a pretty awesome one to kind of be coming onto the scene right now. And there's a lot of bipartisan support that you're kind of seeing for nuclear right now. So I just wanted to kind of open up that conversation. I don't necessarily have a specific question around it, but I think it's
I can ramble about that. I love rambling about that. It's one of my favorite things.
So what are your thoughts on that?
I mean, so I've actually been joking with some of my partners that, like, we have a partner that was kind of the one to originally invest into TCM because they wanted us to become their cloud services kind of arm. We're not part of their company, but we were like, hey, all right, we'll take some stake and whatever, we'll work together. They run the sites. They used to run a bunch of Bitcoin sites. They're transferring all that effort into AI because I've been telling them for years, I'm like, look, this is an actual value proposition. I don't want to upset anybody in crypto. I've made money off of crypto too, but like, it's not sustainable in the long run. It just isn't. Let's be real here. So at least for a lot of things, there might be other projects, whatever. I don't care. The site guys, I joke with them. I'm like, when can I buy my nuclear reactor? When are you guys going to get me a nuclear reactor? Because like, if we do that, we've just won the game. Like Microsoft has announced that they're interested in buying small modular reactors.
They're like hiring positions of people to go out and like figure this out.
If I didn't have the job I have now, I'd be very interested in taking one of those jobs. I think. Yeah. Because it's absolutely captivating.
Fascinating.
It is a hack. It is totally cheating the whole system. It's like, look, we've got unlimited power. We just free money hack right here. And that is kind of what nuclear is these days, especially with the way that reactors are designed. They're so much safer than they've ever been before.
Something that I've been following is just how difficult. So it's capital intensive. Why is it capital intensive? Largely because of how much regulation goes into building a reactor, whether it's a micro reactor, small modular reactor, or a giant reactor. You have to get through all of the red tape that the NRC has imposed, rightfully so in a lot of ways, to make sure that these are safe. There are lots of risks with building a nuclear reactor. But like you said, the new advanced reactor designs that have come on are much safer than anything we've got, but we can't get them licensed through the NRC, which is ridiculous. That's kind of where we are. I don't know if you've been following this, but the Advance Act that just got passed through Congress, I believe, is aimed specifically at cutting through the red tape.
Really?
And basically it's saying, okay, China's figuring this out and they're way ahead of us in terms of the amount of reactors they're bringing on. We've got to figure out a way to be competitive in terms of building these reactors and kind of, creating a market.
Yeah, I mean, a lot of people look at the EU as kind of like the model that the US should take for regulation and how intense the regulatory bodies can be over there. I mean, they really do call the shots. So they told Apple to just get rid of their proprietary connector. We don't like it. Make it go away. So that's a huge amount of power that they have over there. And literally they have a lot of power over there because they do allow nuclear reactors to be built. Like they do actually encourage that. They do seem to have a framework around that for as much as people want to poo-poo at the EU's regulations and how hard it is to run a business, which is a fair, it's a fair argument to make. But apparently they're getting it done. France has more nuclear reactors than anybody.
I know.
It's France. Like
it's France.
It's France. It's amazing. Like, I mean, no, it's something that they do really, really well. And it's like, why are they able to do it and we're not? Like, they're more regulated than we are. Their overall economic productivity per person is lower than ours. How are they getting this done and we're not? What are we doing?
Yeah, it frustrates me. It just, like, back to the conversation around energy and like, we need more energy if we want to start onshoring some of our manufacturing again, just from like a national security perspective. Like it plays into so many different parts and it just frustrates me to look at ourselves as a country that used to build things so quickly and like have so much innovation. It just takes so long and it's so
quite a bit.
expensive to do it. And it's just frustrating. So
it's not a lack of passionate people. I don't think it's that. So.
No, it's not. No, but I do feel like the tides are kind of shifting, at least around nuclear. There's more public sentiment is kind of shifting and policy seems to be supporting it. So hopefully we'll see some good progress there.
Love to see it be easy for us to just order a micro reactor off of a truck and then, get a crane out. And
no, honestly though, like just like a big shipping container, it's got a little micro reactor in it.
I mean, I've seen the designs from, was it NewScale?
Yeah.
I got my
super
SMR
cool.
stocks.
No, I could go on and on about that stuff.
I could too.
Let's shift back to kind of AI at the broader level. How do you view this current sort of emergence of AI as an industry? Is it the real deal? Like when you think of crypto and Web3 that we're kind of, I'm not going to say fads completely, like there's probably still some utility there, but how do you compare the two there? Like how do you view AI in that same light?
Yeah. So like, I mean, first off, just to touch real quick on the crypto stuff, I never saw the value of crypto necessarily being the financial services. It was the decentralized model.
Right.
It's like, this is actually really redundant and it just, there are more failure points, but also more resiliency across this entire network, which is really cool. AI hopefully will do the same thing. We'll see the same things happening there. We're kind of part of that effort to some extent, although we are a data center company and ourselves, we put them in under one roof. So we're not really decentralized.
Mm-hmm.
We talked about this a second ago, and like this idea of, automation has been touted for years and years and years as being like, it's coming, it'll save you from the toils of labor and all this and that. And it's true. It has happened. Like, the Green Revolution happened. Look at that. We used to be an agrarian society, and now 98% of us don't have to work on farms. I grew up a farmer, so like I talk about this all the time. I'm like, oh, look what it's done to us. But at the same time, like, look at this. We can go further up Maslow's need hierarchy and actually do more just like complicated things as humans because we're capable of that.
Yep.
AI is in this current iteration. I think it is the real deal. What is that entirely? It's not like having Jarvis that you just talk to all the time, but we have Alexa. So, we're getting there. We're definitely getting there. And the way that things are now, it is downright impressive to see the level of like advancement that has occurred in the last 10 years here to where it's like, okay, no, this actually is useful for a lot of things. Mm-hmm. We were drafting a press release for something the other day, and like a couple people on my team were like, was this AI? And I'm like, it was written better than most of our old press releases. Well, but yes, partially. Yeah. Why not? Yeah. I use it to augment a lot of the parts of my average day just using large language models. And that's just one, that's just the hot topic right now. Everybody talks about, ChatGPT and stuff like that.
LLMs.
And that's only one component of all of this. You can look at all kinds of things like resource extraction from like the USGS, the US Geological Survey. They use AI to find out where new untapped pools of like underground resources are using predictive modeling. It's crazy. It's weather forecasting. It's getting way better.
That was last week's episode. We had Climate Vision on there up in Louisville. They built out a radar network and partner with low Earth orbit satellites. So cool. And they just acquired a company that's doing generative AI weather forecasting. So had a whole conversation around that just last week.
I have to go check it out then.
Yeah, it was a super cool conversation.
I grew up a Midwesterner, grew up a farmer. We're obsessed with weather. Twister's all of our favorite movie. Yeah. I figured maybe because of the movie just coming out that you guys did that one, but that's exactly what I'm talking about though. Like you can do that. You can do protein folding and unfolding simulations. New drug therapies are coming out, all because we have the ability to analyze huge amounts of data without one person having to have that full big picture in their head. There have been geniuses throughout the past that have done this, but that's not something the average human can do. There's just too much information to be able to process it and actually be able to give weight to everything as if it's important. We have billions of data points. So yeah, this is real. It's doing a lot of things for us, and most people don't realize.
I don't think so.
Where it interfaces with their lives. Just last mile delivery services. Amazon being able to hit your house in like 4 hours. In my area, I live in Georgia right now. It takes 25 minutes to get some deliveries from Amazon. That would not be possible without AI optimization.
Yeah, that's crazy.
It's crazy fast. So I do live pretty close to a distribution center. Yeah. So there's always like their little Rivians driving around or whatever. But like it is here. It is changing lives already. And there's other concerns to have with that. But I think, it is making a meaningful impact on how things are done work-wise.
I feel like one of the next kind of phases that we're going to see is like we've got these LLMs that are coming out and people are using, like write emails or process copy or articles, whatever. That's like, I feel like how the average person is kind of using it right now. I think what the next kind of wave of how do normal people use AI is going to be when AI allows you to string together multiple agents that can kind of perform a complex task. Right. But then also when these agents are able to actually take actions online. Yeah. So it's like, call me an Uber. It knows how to interface with the Uber app and go calling you an Uber. I don't know how far off that is. That's a scary kind of thought to think about, of like stringing together multiple agents that do complex tasks and then being able to allow them to take action on your behalf online.
Yeah, letting them out of letting them out of the box, letting them have internet connectivity is kind of scary for a lot of people, but it is already happening. It's obviously already a thing. You've seen some of the stuff.
There's a research article. I only read the first page of it, but that I saw actually just yesterday on X. Somebody was like, I want to test if how AI agents can propagate themselves online if we kind of put them in a sandbox and let them like have a goal and see if they can
give them $100 and see what they can do with it.
Yeah. And apparently,
can you turn this into more money?
Yeah, apparently it started like changing its own code and like doing all sorts of wild stuff that was not expected. And the person that tweeted the research paper was like, yeah, my alarm about this is now on an 11 after seeing how this kind of did its thing. So that is, I feel like, something that not many people are worried about yet, but that seems to be coming down the pipeline. Yeah, it's like when we turn these things loose on the internet.
It's like John Henry versus the steam shovel, right? Like, I think people are always intimidated by big sea changes because they just don't know what's going to happen next. And that's fair. That's only human to be worried about that. I am worried about it to some extent. Like, this could go bad. It usually goes pretty well. Like, we haven't ended the human race yet. Fingers crossed.
Yeah. Let's kind of talk about the existential side of this.
There you go.
That was kind of the where I
didn't mean to wander in there, but we always do.
It's kind of where we're going. It's
kind of the conversation, isn't it?
Do you view AI as like an existential threat, or how should we be thinking about the existential side of this? Like, this is a pretty significant, maybe the last significant kind of technological revolution that humanity may go through. We had like the agricultural revolution, then the industrial revolution, then the information age. Now we're kind of like at a point that might end up being kind of the final point, which is we're creating software
replacements
that is smarter than humans.
Yeah.
And that's that's a pretty crazy thing.
Yeah, we've had software that's smarter than humans at like certain things for a long time. It's just been very contained.
Yes.
We talk about like keeping things in the box. Like a calculator is generally better at doing math than me. So I do enjoy doing math stuff, but like at the same time, you get the point. Like we already have outsourced these tasks to technology, and it didn't ruin the human race then. As for AI as it is right now, like as a tool, no, it's a great set of tools. Like I can see how it could lead us down a path, but like my bigger concern is like, okay, if we can actually like Neuralink is a thing right now where people are getting brain chips. That's what actually scares me is people that are going to be like transhumans, as it were.
That's like, a new species is what I've been saying.
Yeah, new species.
You're not Homo sapiens anymore.
Yeah, I don't mean like trans, like I mean like transhumanism is like this concept of like we have modified ourselves now to where we're like cyborgs or whatever. Yep. That to me is like something that I'm very trepidatious about the idea of having.
I agree.
Like if you're a brain chip enabled human, well, you're going to run circles around me.
Can you interface with AI directly into your brain? You're
right. You're going to talk about economic like disparities now. Oh man, it's going to be over for anybody that doesn't have that.
There's a whole freaking ethical rabbit hole you can dive down there.
Yeah.
I think when I think of like the existential side of artificial intelligence, it's more so around the pursuit of like general artificial intelligence.
Yeah.
To where it can perform any task as well as a human can. And it seems to me like as soon as you get to general artificial intelligence, then you've now got an artificial intelligence that's going to be better than a human at improving itself.
Yeah.
And then you get to super intelligence.
Yep.
And I don't think it's your guess is as good as mine or anybody else's around when we actually get there. But like that seems to be where things are heading. And then you combine that with this age since social media of collecting all of this data, like everything that we do is a data point now.
Yeah.
And we're feeding a lot of those data points into these models. It's like, that seems like something that would increase on an exponential scale. And I'm hoping that it doesn't catch us off guard how quickly we get there.
I think the good thing about what you're talking about social media is that it's all garbage in, garbage out. Like we're going to make some great like meme lord AIs, but like, are they really going to be that much smarter than us? No, they're just going to be really good at making a banger of a Twitter post or whatever, Like, I mean, and that's not necessarily practically useful. Entertainment is entertainment, but like, I don't think that like training off of all of social media is like necessarily a threat. I think it's when you train it off of really good data that it becomes more of a threat. But without the labor component being there, without automating away labor, it's impossible for the AI agents to do all this stuff on their own. With the advancements in cybernetics and technology right now, like being able to build robots that are able to do what we do but better, that's when it gets scary, is if you put those two things together and say, now we've got Terminators. Whoops. Like, you gotta be careful with those directives.
Figure's doing some crazy stuff. They just came out with like their Figure 2.0 or whatever. Do you keep up with Brett Adcock and Figure? Definitely. They're essentially, they're building, it's a robotics company. They're building humanoid robots, but they're putting, rather than like programming the robots on what to do, they're using large language models and AI to like allow it to comprehend its environment and like do stuff off that. You should watch some of the demos. They're pretty wild. Yeah, but when you get to a point where AI is now able to interface with the physical world and learn from interfacing with the physical world, and then combine that with everything that we've already, all the progress we've made in the digital world, like it's kind of a scary future.
No, that's why Palmer Luckey, despite his colorful shirts, is one of the scariest individuals on the planet. Because like, bro, you're putting AIs into missiles. This is frightening.
I just put this on my story yesterday. Did you see the American Vulcan article that came out? It's like a whole synopsis on Palmer Luckey. It's a long article, but it's on like Tablet magazine. I'd recommend anybody listening to this go and read that. But it details Palmer's like journey from VR and then getting acquired by Facebook and now building Anduril. For those who don't know, Anduril is a defense company that's contracting with the U.S. government to build autonomous weapon systems, which sounds as terrifying as it is.
I mean, Lockheed's already been doing it, but he's the one out in the front of it. He's the face of it.
Yeah, the thing that it talks about with like Lockheed and some of the prime contractors is that it's like the incentive model is just fucked. Like it is to the point where they're on a cost plus revenue model. So like they literally make more money if they take longer and hire more people to do the projects. Whereas, Anduril's kind of flipping it on its head. Yeah. Anyway, that's a total tangent that we can go on, but
no, but it is
highly recommend.
I would love to. Yeah, I'm going to check that one out because like that is something that is of great interest to me because I've always just really been interested in just military technology. I'm a dude. I grew up in Kentucky, United States during the Patriot Act years. Of course, we're all like, rah, rah, these are cool planes and whatnot. But when you look at like the Lockheed like marketing videos for the LRASM missile, it's like this completely autonomous naval like warship destroying missile that if it loses full connectivity with everything, no, it will still hunt that boat down. It will evade any countermeasures it can and will still try to hit the target based on literally just visual identification, which I'm like, it's not a reliable process.
Yeah.
It's mostly reliable. 99.9% is pretty dang good unless you're killing people with a missile. Like that's terrible. Like it's a pretty frightening thing.
Yeah, no, I agree. Terrifying stuff. And I'm sure we could go on and talk existential threats, but to wrap things up, to bring it kind of back to Kentucky, bring it back to our focus with the podcast. What was like talking to people about building a startup here in Kentucky? What do you view as the perceived like benefits and disadvantages to building a startup in Kentucky?
Well, I'll start with disadvantages, so I don't have to end on a sour note with that. Disadvantages is that we don't have the capital here.
We hear that a lot.
I mentioned that we had to kind of dumbing down's the wrong set of words to use for like how we describe what we do. It's like reframing it in the right way to where people understand it. Having to do that, I think that was actually a really useful exercise for us. That was very helpful for us to have to do that. Like the circumstances here required that we learn how to talk about it in a way that people understood. And I think that was actually a really good thing, but it is kind of a disadvantage at first because you're like, hey, I'm very excited about this technology. If I went out to Sand Hill Road and tried to raise money in Silicon Valley or whatever, I would probably be able to get somebody to at least know what I'm talking about.
Yep.
And here people will kind of like it. I've had some negative experiences with some of the funds around here. I won't drop any names.
Yeah.
But generally speaking, it's really hard to get them to believe in seed stage companies. They want to see revenues for things. And I'm like, that's not how companies are done these days, unfortunately.
We hear that a lot. Yeah.
And I think you should build a company with customer demand first and then fill that role and then actually have money. And then like you can go raise money after that because you have a pattern and a trajectory that you can build off of. But a lot of things can't do that right out the gate. A lot of like conceptual technology can't get off the ground without some seed capital in the first place. And there's just not a lot here. Yep. They do kind of farm us out a little bit to the coast. That's another negative thing. Like funds here will talk about how great it is that they can package together deals of wildly undervalued startups and go get really good deals with their buddies on the coast because they're like, yeah, this is a steal. Yeah. Because it is.
Yeah, you definitely, as a founder, my roommate in the coast of Middle Tech, Evan, for his last startup, he went out to the coast and started fundraising, and he had a few people laugh in his face when he told them the valuation that he was shopping around Kentucky and then tried to use the same valuation out there. They're like,
what are you doing?
What are you doing? Like this,
we don't get out of bed for this.
That's ridiculous.
Yeah, we don't sign checks under 10 million.
It is something that like it's kind of a cultural shift that kind of needs to happen here, and like there just needs to be more exposure to how different it truly is. Yeah, it's a culture thing. Yeah, but we do hear that a lot. But what about some advantages?
Positives though? I mean, it was exciting stuff. I mean, like really like. The thing that I've learned about working in Kentucky is like, I mean, and also working out on the coast and things, nobody's from Los Angeles. They all move there. Like they're all people from other smaller communities that have huge potential and they're drawn to these places as part of the brain drain. And Kentucky like has a lot of great minds here. There's a lot of great talent here and like it's underappreciated. And I mean, I hate to sound like I'm exploiting that to a certain extent, but in reality, it kind of is that. It's like I exploited myself here, like to say like we all do have this huge potential. It's not being seen by, these, without moving out to the West Coast or the East Coast or whatever, it's not going to be seen. So being able to build a company with people that actually are extremely talented, that are probably underappreciated, undervalued, I think that's huge to give people those kinds of opportunities. To be able to even do that in the first place is just it's humbling, really. It's an honor to be able to do that. But I mean, that was the biggest thing that I've seen here is just like the community building that happens in a place like this, where it is a smaller area. Things are a little slower, and that's why I think things can be more genuine. There's more trust that just 100%. Comes instantaneously. Like, no, we're actually in this together. We're not transplants. We're from here. This is our home. Like, and most people I don't think want to leave. Like I talk about how I live in Georgia right now. I still say I'm coming home to Kentucky anytime I come back. So. And that's part of why I haven't given up my apartment in Louisville yet. Because I'm like, no, that's actually me like being out, and I don't want that. So
no, that's the dynamic I'm dealing with too. I graduated from UK about 5 years ago now, and it was always a struggle of like all my friends were leaving for bigger cities, but there was really something that like maybe it was a pride thing, I don't know, but creating opportunity here and figuring out how to find opportunity in a place that I genuinely love. Because like my family's here, a lot of my friends are here. I don't want to leave Kentucky unless I have to, or unless there's an opportunity that I just can't resist somewhere else. And it is. Middle Tech has been so much fun because of what you're talking about, like the community here and the genuineness of it, and like the ability to get people to rally around sort of a common mission. So
it's funny you say it's like a pride thing almost. And I can kind of relate to that a little bit.
Yeah.
It's like,
the
song,
you, I can do it here.
Well, yeah, the New York is like, if I can make it there, I can make it anywhere. I'm like, no, that's Lexington, that's Louisville, that's
more
Bowling Green.
Like
that's if you can make it there, you can make it anywhere in tech. Okay,
so
for
true.
real. Like, and that's been the truth so far.
Yeah. Well, and Ian, it's been an awesome conversation.
Yeah,
super interesting. We got to dive down some fun rabbit
Appreciate
holes. Before we let you go, tell us where, if people want to learn more about the Cloud Minders, where can they go? And then if they want to help, so whether you guys are hiring for anything, raising money, any ways, positions, ways that people listening could get involved, help you out.
I appreciate it. Yeah, I mean, the number one place to find us is, of course, our website, thecloudminders.com. LinkedIn, we're also pretty active, making terrible memes and goofy AI stories. We kind of see ourselves as the onion of AI right now.
You guys have a good
account. We're having fun with it. Yeah, we're trying to walk a
LinkedIn.
line here of not being anything we shouldn't be, but also having a little bit more, letting our hair down a little bit more than some of the other tech companies might. So good places to find us, Facebook, LinkedIn, obviously our website. Things that we're looking for, we're just always looking for more talent to come our way, more people to get involved in our community, whether or not they're going to be employees or contractors or just brains in the trust, as it were. They're helping us out. We love having more people along. Talking tech is always fun. So
is that like devs or
developers usually, people that are into networking, things like that, site building, things like that. Like people that are into nuclear reactors too. We like them because power is the name of the game sometimes.
That's right. Well, cool. Well, if you're listening to this and you want to reach out to the Cloud Minders, what's the best way to do that? Probably just through the website or LinkedIn or
we have a contact form on our website, and then we have our LinkedIn page as well that people can reach us at. And then I think we're actually probably the most responsive on Facebook messaging, honestly, which is kind of boomerish of us. But look, it's coming back. Okay,
it's coming back.
It's coming back. Like Snapchat came back, Facebook's coming back. All right, so
awesome, man. All right, thanks so much for the time. It's been awesome.
Thank you.